Okay, so we're back in this video here. So I think the next section I was talking about like graphs, and we kind of talked about that, right? So if we took like a little graph, right? You guys have all seen bar charts before. I'm using my stupid lazy printer, right? We know that sometimes they're summarized like this. We have a bar here, we have a bar there, and it kind of looks like that, right? And so what would we know about this, right? So we know in this first one, if we were kind of describe it, like this would be a unimodal graph. And so in this case then, because there's this one data point, like right here, that's really influential. So one occurs more than others. This is what's going to be called the mode, right? So the mode is the most frequently occurring value. But sometimes if we think back to our gang example earlier, right, we had 4 different categories, right? So what we had? We had like, it was like the Crips, and then there were like Bloods, and then there were Latin Kings, and then there were here, right? So this graph is different from the other ones, right? Because we notice here and here, there are 2 that are commonly occurring, right? Now they are not exactly the same, right? But we could say that this is bimodal. And so this could be like 2 commonly occurring values. So people in that prison, right, were more likely to be Crips and more likely to be Latin Bloods, right? So this is going to be 2 commonly occurring values. So sometimes though we have data like this, right? There are other kinds of graphs that we have, and sometimes we're interested in skew. So this is going to be where data are stretched in a direction. Oops. In a direction. So when you think about this, right, sometimes if you think about like a spread of data, right, it kind of looks like that, right? Although sometimes what can happen, right, is that we have it way out here and then there's this little hump, right? So the difference between these 2 graphs that we see here is this right here, right? So this is going to be an example of skew. And what this kind of skew is telling us, right, is that there is like this stretch that is happening within the data, right? And so let's talk about how like this can like differ, right? So if we think about, if we drew something like this, and then we drew like a big hump, and then out here, right, we're usually, like the way that we define skew is by these tails, right? And so what would we describe? So now you might think, looking at like this first graph, right, so on this right, like right here, you might think that, oh, this is skewed to the right, but this is actually skewed to the left, right? So this is the left skew, and this is right skew. Because we're interested in the tails. Interested in the tails. So in this part, man, is this, maybe we're gonna do maybe one more finer? I don't know, we'll see. So we're interested in the tails of the graph, right? And this has importance because this affects the center of the data. Oh, that's much better. And when we think about like what the center is, right, since this is like what we're usually interested in, it's helpful to know that the skew can influence our results. And this is usually why the mean or the average can be hard to trust. But it's something to kind of hold on to, right? And it can tell us info about the data. All right. So let's talk about a few other things, right? So let's talk about we'll talk a little bit about the mean, right? So you guys would probably remember the mean, basic third grade stuff, right? And again, as we already talked about, this is the average, and this is going to be, sometimes it's called the expected value. From a stats point of view, sometimes it's like hard to write out the mean, sometimes it's hard to write out the words, and that's why a lot of people come up with different symbols. And so usually what happens, right, is that we'll come up with a symbol. And so just a symbol to keep in mind, right, for this class anyway, we're going to do this as X and put a little bar over it, right, a little dash, and this is called X bar, right? But keep in mind, right, that this is maybe a little thicker here. X bar, right? And so that's how that's symbolized. And so when we say, oops, didn't mean to zoom. When we say we have X bar, and this is going to be equal the average, we have a different way of summing up. Now, you guys may remember, if we think about like how we solve this, right? We usually take add all numbers, and divide by how many numbers there are. Now, when we think about like that, right, it's kind of cumbersome to write all that out, right? So the way this usually gets summarized is to use the summation symbol. So like this goofy looking E, it's called sigma. And we sum all the X and we divide by the number of them that they are. So let's take, for example, just a real quick to break it through in case people forgot, if we had 7, 17, 13, 4, 12, and 11, right? So how would we go about solving this, right? So we know, first of all, so if we added all this up, so we added 7, and I'm using a calculator, plus 17, plus 13, plus 4, plus 12, plus 11. This is going to equal 64, right? So the way that we would go then is that we were finding X bar. It'd be 64 divided by 1, 2, 3, 4, 5, 6, 6 numbers, right? So it'd be like this. 4 divided by 6. And this is going to equal 10.66666667, right? And for our purposes for this class, we usually, unless stated otherwise, to solve at 10.66 and like call it there, right? Or I guess this should be 7. Yes, 10, this should be 7. Sorry, we're going to erase that. So this is going to equal 10.67. So that's how you found an average, right? Pretty easy, doesn't really matter, not too hard to figure out, right? There are also other measures of central tendency that we're looking for, right? And in this case, right, one might be the median. So if we think about the median, this is going to be the center of data, right? And so what we end up finding out, right, is that this is the middle point of data. How would we find this, right? So if we look back at our previous example, you know, we have 4, 7, 11, 12, 13, and 17. Is that right? Yeah, I guess so. So the way we'd find it, right, is that we would first cross out this one, and that one, this one, and that one, and this one, right? So we get up with 12, would be like the median of the data. Although, you know, that might be, but we also have like this center issue. And so if we think about usually what ends up happening in those situations, right, is that you add the numbers and divide by 2. And in this case, that's 23. And what is that going to be? It's going to be what, like 11.5. And so the median may be 11.5. Point being, right, is that this is like the actual center of the data. And the point of that is that there's going to be 50% below that number. And there's going to be 50% above the number. Sometimes we're also interested in the mode of data though, right? And so this is frequently occurring. So if we had 1, 3, 3, 7, 3, 6, 8, 9. What we know right here is that these data are unimodal, and that 3 occurs most often. And so when we think about this, right, basically the mode's looking at what frequently happens, right? Then we're also interested in the range. This is the difference between small and largest numbers. And so what would end up happening here and what we try to figure out, right? So this previous example, so this would be, we have the highest number, which is 1, and here is 1, and so that range equals 8, right? At the same time, if we had a different number set, let's say we had 3 numbers, and then that was 12, was the highest number, and that range would equal 9, right? Basically, again, we're looking at the difference between small and largest numbers in a set of numbers. So hopefully that seems like a refresher. And so we'll hopefully see you guys next time, and we'll kind of talk about some more of this.